Hello, everybody. My name is Chandra Nilogal. I work in the Dell Technologies Infrastructure Solutions Group, focusing on data storage and security technologies. And I'm here to talk about NVMe Key Per I feature and the benefit it brings to the table for enterprise.
My name is Festus Hatajekimana. I do security architecture development work at Solidigm. And today I'm excited to talk a little bit about NVM Express Key Per I feature, its overview, and some of the challenges that OEMs, hyperscalers face today that Key Per I help addresses. In terms of the overview, Key Per I is a new feature that's been developed by NVM Express with collaboration from the Trusted Computing Group, TCG, with the high-level goal of providing a more dynamic and granular access to storage devices. And the way Key Per I does that, it allows storage systems to leverage their own custom key management systems or the end-user key management system to control the boundary of data encryption within storage devices. Specifically, it allows storage systems to provision their own data encryption keys within volatile key cache of storage devices, and to select which of those keys are used by the devices at runtime on I/O on per I/O command basis. These provide benefits in terms of allowing storage systems to dynamically scale the number of tenants they can allocate to storage devices namespaces, and to control data erasure on a granular level that would not have been possible before. For example, if you have distributed data objects that span multiple disks and you want to be able to erase a particular object or a particular file, Key Per I allows you to do that in ways that wouldn't have been possible before. There's also a number of other management capabilities that it provides over existing implementations.
Existing storage device implementations that encrypt data with the data encryption keys are generated and managed by the storage device themselves and are maintained within the storage device alongside with encrypted data. With the new NVMe Key Per I feature, it enhances the data encryption capabilities by allowing the data encryption keys to be generated and maintained outside of the storage device. And again, they are not stored persistently on the storage device. So every time you have to provision them. And this enables the key management to be done by the host while ensuring a scalable tenant isolation support and expanding granular host control to devices, namespaces, and storage regions.
In terms of challenges that hyperscalers and OEM face today that Key Per I help resolve, the number one challenge really is being able to use your own key management implementation or the end user key management system to do data encryption for data that gets stored in storage devices. Today, prior to Key Per I, there wasn't any native capability to storage devices to allow end user to use their own data encryption keys that they control, stored in their own external hardware security modules to encrypt data that gets stored inside storage devices. The second challenge that this Key Per I resolved is around the scalability of the number of tenants that hyperscalers or OEM can allocate to storage devices namespaces. Existing systems on storage devices rely on static key management implementations that fail to grow dynamically as the host want more space to allocate more tenants. Key Per I solves this natively by allowing the host to provision any number of keys they want to associate to any number of tenants and to swap in and out those keys inside the device key cache. There's also a number of challenges in terms of managing the device namespace availability to tenants without needing any tenant innovation. Existing workarounds rely on software encryption layers that get added to data before it gets stored on storage devices, but that comes at the expense of overall storage system performance penalties. Key Per I allows storage system to do that, just that, without any associated performance penalties.
One ideal use case for this NVMe Key Per I feature is data erasure, or process of clearing the tenant data from a storage device when it is no longer needed. The NVMe Key Per I host with NVMe Key Per I host can easily delete specific client data that is spanned across multiple storage devices without needing to go through a more drastic step, something like erasing a band or erasing an entire storage device. Additionally, the Keeper IO helps free up the additional space to store the media encryption key themselves. And the other thing is, using the Keeper IO, data center host can dynamically create or delete RAID volumes or erasure coding when they shred the data that spans over multiple namespaces, multiple devices, multiple enclosures. A same data encryption key can be used to encrypt all the data that is spread across. Essentially, by allowing the host to associate a data encryption key with dynamic data that spans multiple namespaces, multiple devices, which may physically be located in different enclosures, different server platforms. The Keeper IO enables a host to establish a cryptographic isolation between tenants and between tenants that run on the host application, and also data erasure capability, and which guarantees isolation all the way down to an LBA level.
There are a number of resources available to learn more about Key Per I. I encourage you to check out the 2023 Flash Memory Summit presentation on how to use Key Per I. I also encourage you to check out the nvmexpress.org website. It has information on Key Per I specification and a blog post on the Key Per I feature, its benefits, and challenges that exist today that Key Per I help resolve. TCG also has specifications on the Key Per I available publicly. There's also the application note that's available that shows how Key Per I is used for any implementers and designers that are considering to use Key Per I in the storage systems.